Thank you, everybody, for joining us. If you have any questions whatsoever, you can always ask them in Zoom. If you don't want to use Zoom, you can ask Discord. And in Discord, your fellow attendees may help answer your question faster than any of us can. This is recorded, so if you want to watch the recording, you find it on YouTube. The slides are available on Discord. We'll also put them here in Zoom. And that's it for me, Logan. It's all yours.
All righty. Without further ado, let's take it away. All right, so I'm here today to talk about cyber deception, honey tokens, honey pots, that sort of thing, and how it ties in with AC Hunter and threat hunting in general. Last year, we started on a new project to incorporate cyber deception into AC Hunter. And as one of the developers on AC Hunter, I've never really worked too much with Active Directory and the Windows sides of things. So it was a big learning experience for me. And we tied it into the project and we've automated so much. I wanted to share what we went through and what we learned along that process with everyone else in the community. So let's go ahead and get into it. So here's what we're going to talk about today. We're going to talk first off, why implement cyber deception. I'm going to try to sell it to you a little bit as opposed to relying on traditional detection signatures and that sort of thing. We're also going to take a look at how attackers might behave inside of a Windows network, particularly an Active Directory network. And then we're going to take a look at how cyber deception can help defend and track those behaviors. And then after that, we're going to get into the nitty-gritty of things. We're going to look at a couple attacks and a couple of detections that we can pull off with cyber deception. You're going to see this term honey tokens thrown around a lot. What that just means is that we have some sort of fake resource that we want to try to trick the attacker into interacting with. And then finally, we're going to look at how we can automate some of this with AC Hunter. So if you go on the internet and you ask, what is cyber deception? You get these long, loquacious statements that cover everything under the sun. And you know, they're actually pretty good definitions. They just don't really work for me because I have the attention span of a gnat most days. So, you know, when you have the time, take a moment, internalize these definitions. They're good definitions, but they're a bit much for what we're going to be talking about today. So I'm going to try to boil this down a little bit here. When we're talking about cyber deception today, I want to break things down into three different components. We're going to have the ruse, the expectations, and the benefits. So the ruse consists of a false story that defenders tell attackers. And that can consist of both true components and false components. So you might have your false users, let's say, intermixed with your true infrastructure. And you have to figure out what are the right components in order to falsify, in order to trick the attackers. So let's say that the attackers buy into your ruse, buy into your false stories, and they take some sort of actions. Well, we also want to be able to predict what kind of actions the attackers are going to take with respect to the traps that we lay. So we need to have some sort of expectations of what the attackers are going to do given our ruse. And then this isn't always part of the definition, but I find that it's helpful for today. We're also going to look at the payoff or the benefits associated with laying those traps for the defenders. We want to make sure that the defenders come out with a competitive edge against the attackers rather than just setting up infrastructure for not a lot of good reasons. So with that, let's talk about why we might implement cyber deception in general. Well, when we look at a traditional attack against an enterprise or Windows network, it takes quite a while for most people to find those types of attacks on their networks. This is getting better with proactive threat hunting, hypothesis-based threat hunting, and we offer tools like AC Hunter that helps you go through network data to search for command and control channels, that sort of thing. But at the end of the day, we're still detecting attacks way too late in their life cycle. So if we can implement cyber deception and create some alarm bells that trigger earlier in that life cycle, that's really helpful. Additionally, with cyber deception, you can get some reconnaissance on what the attackers are doing. So with a traditional detect, you might get some information about what they're doing. You know, are they trying to obtain greater privileges? Are they just trying to look around on your network? But with cyber deception, when you really have a full story laid out, you can see what they're trying to get at and how they're going about doing that. The other nice thing with cyber deception, especially in the Active Directory environment, is that it's very low investment to get started. Windows and Active Directory provide a lot of auditing tools that you can use in order to watch for interactions with different types of resources. And you don't necessarily have to pay anything to get started with this other than time. And then finally, when you combine this with services like web bugs, it can actually help with attribution. One of my favorite sites out there is Thinkist Canary tokens, where you can generate a URL or maybe a Microsoft Office document that contains a link to that URL. And if an attacker takes that file back to their network and opens it, you can actually get a GeoIP out of their access. And you can start, thinking about attribution that way. If we're looking at cyber deception and we're thinking about how we can implement it for the most amount of people with the least amount of effort, we need to think about what's the most common environment that we want to protect, how do attackers behave in that environment, and how can we instrument that environment in an easy manner that's, quick to pull off and doesn't take up all of our time. So about a year ago, when we were thinking about implementing cyber deception into AC Hunter, these were the questions we were asking in order to better serve our customers and try to make the most impact with the minimal amount of effort. And we came to the conclusion that really Active Directory is just the most common platform for enterprise networks, especially for authentication and authorization. Now, Active Directory handles a lot more than that, and we could have conversations all day about everything that Active Directory does. You've seen whole conferences on this sort of thing. But what we really want to focus on today is some of the different ways that you can authorize as a user with Active Directory. So we're going to look at three main different ways that authorization takes place on an Active Directory network. We're going to be looking at NTLM challenge response. And so the idea behind that is you take like a timestamp and you encrypt it maybe with a hash, and then you send it off. And if they know the password, then they can decrypt it and prove that they know that. That's kind of the idea of the challenge response. And then we also need to take a look at LDAP, which actually stores the whole directory of information. So that's where your users and computers and organizational units will be. You can use that in order to authenticate as well. And finally, we're going to be looking at Kerberos pre-authentication, and that's kind of like a challenge response protocol, but it goes a lot further, and you're using multiple systems in a way that distributes trust in order to authenticate the different resources using Kerberos. Now, when we look at authorization instead of authentication, so we've already proved who we are, we want a resource in this case, that's going to be handled using the Kerberos protocol, and you get into this whole business with tickets being passed back and forth. And so I don't want to dive in too deep to these topics right now, but just know that there are a lot of different methods that you can use for authentication with Active Directory. Authorization is usually through Kerberos. And when we go to set up cyber deception techniques, we need to make sure to keep an eye on all of these different protocols in order to support our detections. In order to create something that will deceive an attacker, we need to know how those attackers are going to behave in the first place. One of my favorite resources for this is the MITRE attack framework, especially since we can go in and we can filter it down to just those techniques that are used by attackers in enterprise Windows networks. And so if you go into here, you're going to see all sorts of different techniques that attackers can use on the network in order to find more information, to escalate privileges, to exfiltrate data, all sorts of stuff. And the one reason I prefer the MITRE attack framework to some others is that it doesn't really create a narrative of how the attack plays out. It's just a really good categorization of the tools that are being used and links to IOCs where these techniques have actually been used. Lots of good information there. Atomic Red Team is also an amazing tool. And what that listing there does is it shows you how an attacker might pull off each one of the techniques that's included in the MITRE attack framework. So you can use this in order to automate testing your defense infrastructure against these different types of attacks. So we're going to look at a few different techniques in the MITRE attack framework today and how we can build deceptions in Active Directory in order to track and detect these sorts of techniques. So first, we're going to be taking a look at password spraying, which is this idea where we take a single password and try it for a bunch of users. If it's a really common password, maybe you have a password rotation policy that forces people into a certain pattern with passwords, you'd be surprised at what you can pull off by just, trying summer 2022 against all the users in the directory, that sort of thing. Next, we're going to look at a technique called Kerberoasting, which has to do with service tickets and authorization in Active Directory using Kerberos. And it's a way that we can essentially get a hash of a password, take it offline, and try to crack it. I'm going to be setting up some detections for that. And finally, we're going to be taking a look at ways to detect people looking for credentials and files on your network. Kind of the old ploy with this is that maybe you had a local an administrator that needs to change the passwords on the local admin accounts on different computers. They might leave a password in clear text while they're writing a script to do that. There are better ways to handle that, but it's common enough that you see it on different networks, especially older networks. And then finally, we have this file directory and discovery that's really just related to finding credentials and files, and the same techniques that we use in order to create honey token files, we can use to detect that technique as well. So now that we've kind of identified what techniques we want to defend against using deception, we need to figure out the techniques associated with those attacking techniques. And MITRE Defend is a framework that's come out fairly recently that maps the attack techniques and patterns to countermeasures. Two that we're going to be looking at today are decoy user credentials and decoy files. And you can see here how those map onto the entries from the MITRE attack framework. Let's take a look at how we might deploy a decoy user credential into our network. So first, we need to come up with a ruse. Now, this is going to be very simple just for the purpose of this presentation. In real deployments, you would want to come up with a lot more details for your ruse. You want to make it as believable as possible. You want it to blend in with your environment. So if you have normal procedures and policies for around users, you want to make sure you're following those while you're creating this fake user. So our ruse here is that we recently hired a sysadmin to manage a new SQL server for maybe a development project, and a misconfiguration was made that associated that administrator's account with the SQL service, which makes it vulnerable to Kerberos attacks. If we have this high value account sitting in the directory, it has a misconfiguration, we have a couple expectations about what the attackers might do. So if the attackers run a password spray, they might attempt to make an authentication request against that account using one of the various protocols, or they might attempt a Kerberos attack, and in doing so, they're going to request service tickets under that account. And the nice thing is we can detect all of that using Windows auditing and event logs. So the benefits are that we will know when the attackers are seeking further privileges right away rather than waiting for behavioral analytics to kick in or that sort of thing. In order to get started with this, we need to set up some audit policies on our Windows servers that control the authentication flows. So usually this is just going to be your domain controllers. You can either set these up individually, host by host, or you can use group policy in order to set this up. So here we have the different audit pull commands that you might use if you are going to be doing this manually, or you might find the GPOs under the advanced audit policy configuration heading. In particular, for detecting failed authentication attempts, we're going to be looking at the logon and Kerberos authentication service categories of the audit policies. Additionally, in order to detect that Kerberos attack that deals with the service tickets, we're going to need to enable the Kerberos service ticket operations category. This one's probably going to be the most noisy category that you enable. The logons and logoffs from the previous page, those are enabled by default. This one, however, you're going to see some more logs that you wouldn't have normally, and there is some noise in that. The nice thing is that we can filter on this in order to come up with detections, so we don't actually have to necessarily store everything that comes across. And we can look at how we deal with the logs a little bit later in the presentation. So once you have those 3 audit policies set up, you're going to see these set of Windows event logs pop up in the security log. Now, being a Linux guy, I only had a cursory knowledge of how Windows Events works when we started working on this a couple of years back. And I had to do a deep dive on how Windows actually stores all of its logs. So, it's probably pretty well known, but all of the Windows event logs come keyed in on these IDs. And these IDs are stable across the different versions of Windows. They always have the same topic. The annoying thing is that the schema might change from version to version. So I believe pretty much everything we're going to be talking about today only applies to Windows Vista and above, because older versions didn't have as much rich information, particularly in those logon events. So we're going to want to search for these different Windows event logs, and we're going to want to filter them down using whatever the decoy user we created, whatever their name was. And as soon as we see an event log with their name pop up with one of these IDs, we know immediately that something bad is happening or something abnormal is happening. These resources, these fake users shouldn't be accessed during normal day-to-day operations. Let's take a look at how we might create a decoy user honey token once we have those audit policies in place. So you're going to need to create a new Active Directory user. You're going to want to follow any organizational norms that you have around creating and enrolling users, just so that way if an attacker's poking around, it looks like it blends in. You're going to want to log into that account at least once, because you can filter on the last login date. And if it was never logged into, that's a really easy way to reject that user account as an attacker. You're going to want to make sure that it has some sort of admin privileges. When we're looking for different accounts to attack on the network on the red team, we often just look to see if the admin account or admin count flag is 1. That just tells us whether or not account was an admin at any point in history. So maybe if you don't feel comfortable putting them completely into a privileged group, you could put them there and then take them out. That'll help you get past some filters. And then in order to make the Kerberos attack viable, you need to associate a service principal name with that account. And generally how that works is, let's say you have a service on your network that needs to access resources with the permissions of some user. You can associate an SPN with that user, linking that service to them. But that means that the Kerberos controllers are going to be able to give out tickets that contain or are encrypted with that hash of that user that you're associating it with, which means that's vulnerable to attack. So we need to come up with a SPN to associate with that user. I highly recommend looking at Sean Metcalf's list of service principal names from a few years back. A lot of them are still viable, and he has a lot of great notes about, this account should never be an admin. This account is usually an admin. It really helps you blend in and make it look like those services are actually there. Now, you can also, if you want to go a step further, add maybe like a honey ports program, some service that just listens on those same ports that those services would and alerts you if anybody tries to connect to those. That's a great way to make those SPNs look valid. So here we have an example of creating a user. It's just a little bit of PowerShell here. I'm not going to dwell on this too much because you can also go in and do this via the GUI. The important thing here to look at is this is what an SPN typically looks like, this service principal name, MS SQL, and then you have the host of the server that it's sitting on, and then the port that that service is running on. So once you have your fake user created, one attack that somebody might use is a password spray. And a really easy way to get started with testing password sprays is to go download this domain password spray.ps1 script that's out there. I believe this is from Bo Bullock and Brian Furman. And you just run it like so, give it a password. You can give it a user list if you don't want to use all of the users in the domain. Maybe you collected a list of admins first before you ran that password spray. And then you can see down in the corner what that might look like. It just tells you, hey, I'm going to try this against so many users. We're going to make sure we don't lock out any accounts. And so when this runs, it's going to be making NTLM requests for authentication against every user account that you provided with that password, which means that we can then go into the event logs and look for the corresponding events that come out of the audit policies. So if you're using that domain password spray tool, you're going to see this event 4625 failed login. In general, we want to make sure these fake accounts have very strong passwords, except for some special cases. And that just means that, if they end up getting a hash of the account's password, they're not going to crack it. That's really what we're concerned about here. So we're going to be looking for failed logons in that case. So 4625 covers LDAP, NTLM, information services. So if you've got a web server that's also providing authentication, you're going to get these events whenever somebody tries to log in to that account. So here we've created a fake account called Sarah Nicholson. We can see that shows up under target username. That's a field you're going to want to filter on. I find that the target user SID is pretty unreliable. Sometimes it works, sometimes it doesn't. If anybody knows why that is, I would love to know why. You will also see how they authenticated in this authentication package name. That's really helpful for tracking down things on the network and correlating it. And you'll also get the source IP address and port. Now, what's really annoying about this is you might get a linked local address. You might get an IPv6, ::1. So you got to do a little bit of work to track down what this IP address is actually pointing at. But if you inventory things and have access to your systems, it's not too bad to track that down. It's just a pain. So if they're not using NTLM, LDAP, or IIS, they might be trying to use Kerberos pre-authentication in order to test passwords against this account as part of a password spray. And a great tool for testing that is this Kerberoot tool that I've linked here. What this does is it avoids the traditional logon systems. It's just going to be doing the prerequisites in order to interact with Kerberos to get, a ticket, granting ticket, that sort of thing. And you'll see this 4771 event ID pop up. It has a lot less information, but you can still filter on the target username, and I find the target SID is usually valid. And the IP address usually comes across as something a bit more readable. If you have IPv4 in your environment, it's most likely going to be that. Otherwise, it's going to be an IPv6 address. Usually you don't see like localhost or anything in here, which is really nice. But you do need to watch both of these events in order to detect failed authentication. If you only have one, you're leaving yourself open to different types of attacks there. So moving on from that, we can look at the Kerberoast attack. One easy way to pull this off is to pull down PowerView from the PowerSploit project and then simply run invoke Kerberoast. What this is going to do is it's going to go see all the accounts that are out there that have SPNs associated with them, and it's going to try to request tickets for those accounts, and it'll give you the hashes that you can crack offline. Now, when you do this, it's going to trigger event ID 4769, which means that a service ticket was requested. And you can see that in the service name field, we have our user that we've set up and made to be Kerberoastable. Unfortunately, in this case, you do see that the IP address comes back as localhost, which can be really annoying. Thankfully, every event log also comes with a section that details the computer that logged it, so you can dereference that in order to figure out what computer it is. But again, it's just a little bit of a pain. And the test tool associated with this is the power view function invoke Kerberos. You can also find scripts out there that include Mimikatz with the Kerberos functionality, and they work just as well. Now that we've talked about setting up fake users, let's talk about setting up fake files. The ruse that we're going to go with here is that the IT team decided for some reason to rotate the local administrator passwords across the domain. They didn't know about things like laps or other extensions that automatically rotate these passwords for you. And they decided to put a logon script in sysvol in order to set these passwords, and the password stored in plain text. Now, honestly, this ruse might not work in a very large environment, but for smaller environments, it has a good amount of validity to it. You see these sorts of things in the wild, unfortunately. So if we have this file sitting out there, attackers might want to read that script in order to access the local admin accounts, because when you have access to those local admin accounts, you can start pivoting all over the network. They're very valuable in escalating your privileges. So we want to monitor for users opening this file, and that way we will know if an attacker is seeking these further privileges, if they're trying to find out what they can get into on our network. So once again, we need to set up some audit policies that we can do either audit poll to set up, or we can set them up with a group policy. In particular, we're going to be looking at two different sections here. We're going to be looking at the logon policy and the file system policy. Now, you might be asking, why do we need logons if we're just monitoring files? Well, one good reason for that is that the file system events include a logon ID, which you can correlate with the logon events. And then from there, you can correlate that with an entire user session. So it gives you a lot more to jump off of rather than just the original file system event that we'll be looking at. So the two logs that we're going to be looking at are 4663 and 4624. 6.3 is going to be our event that pops up whenever somebody tries to access our fake file that we're creating. The nice thing about this event is it has very specific conditions when it fires off. So it's not noisy. You're not going to be overwhelmed with every edit to the file system. You're only going to see when the files that you choose to log are accessed. So you have to set up a system access control list for the file you want to monitor, and you need to enable the auditing on the system that hosts that resource. When these logs come in, they may or may not list an associated process ID. More often than not, they do, but I've also seen cases where maybe you have a network request, the file's on a file share, and we don't get that process ID, which is unfortunate. But you still get the logon ID associated with that request, and you can use that then to find the source IP address when you cross-reference with the account logged on 4624 event. So now that we know a little bit about how to monitor it and what events to look at, we can take a look at how we could actually deploy this out. So for this ruse, let's go ahead and create our file set ladmin password.bat, and we're going to place it in the logon script section under sysvol/script. If you're not into Windows Active Directory lingo, sysvol is a replicated file share that you can use in order to distribute files to all of your systems. We want to fill this file with some content, so that way if we check out the file size on it, it looks reasonable. We want to pass the sniff test. We want to blend in with our environment. And then we need to add that system access control list to that file to make sure that any attempts to read or execute that file are logged. And now you can go further than that. You can also log attempts to read the metadata of the file, which can be nice because it triggers earlier if somebody's just, scanning for files that they're interested in, but not actually opening it, that'll catch it. Unfortunately, a lot of tools scan the file system, so that comes at the cost of noise. So I don't usually recommend that, but if you want to tune it and create safe lists for, what processes can open it. That might work for you as well. So then we have a little bit of code here. I'm not going to go into depth with this, but I do want to point out that you can do this all with PowerShell. You can also do it from the GUI. How this works is we create a file, we fill it with some content, we create a file system audit rule. We're going to say that it applies to everyone. We want it to trigger whenever anybody tries to read the file or execute it. And we want to log it whether or not it's a success or a failure. And then we're going to apply that ACL to that file. Now we need an example of an attack that would trigger this auditing. So what we can use here again is PowerView. So we're going to run the command find interesting domain share file. This is going to look at all of the file shares that we have access to, and then it's going to search through those file shares for anything that contains certain keywords in the names. I believe admin's in there, passwords in there, credentials is in there, that sort of thing. And when you run that, you get some output that you can see down in the corner, and it basically gives you the name of the file, who owns it, when it was created, when it was accessed, and the size. So this is a really useful recon tool if you're on an engagement. And we can see that our fake file pops right up. And then let's say the attacker wants to access that file. They're going to run that get contents. They're going to see whatever we put inside it. But most importantly, we're going to get back event ID 4663. And this is going to tell us what user accessed that file. It's going to give us a logon ID to track the session. It's going to have that object name in there so we can filter specifically on that. And it also sometimes gives us process IDs and process names. Here in this case, I accessed the file over the sysfile network share from another host. So we didn't get the process name, unfortunately. But the nice thing is that it always comes back as the C Windows sysfile path, or if your sysfile is in another location for replication reasons or otherwise, it always comes back as this consistent path. You know, if you're on client computer, you might type in dc1.mydomain/netlogon or something and to look at these files. And even if you access it through those paths, on the systems that are serving those files, we get these consistent paths. So they're really easy to filter, really easy to detect, really easy to work with, and they're not noisy at all, which is why I'm over the moon with this event. So we can do all of that by hand. And if you have a SIM or a log collection framework, you have WEC-WEF deployed and some sort of alerting framework on top of that, maybe you have Elastic Alert, you can go in and do all this by hand. It's just really time-consuming and tedious. The nice thing of when you're doing it by hand is you have a lot of control over the situation. You probably have a really good inventory that you're maintaining, or at least I hope you do if you're doing it by hand. But you know, it creates problems. So I want to talk a little bit now about how AC Hunter can help solve those problems. So AC Hunter is a system that analyzes network data primarily. We usually work with Zeek sensors, but we can also deploy sysmon to individual hosts. We can also read NetFlow data coming out of switches and routers. But suffice it to say that we usually do network analysis to find command and control traffic that's communicating between your network and an attack. However, this is pretty late in the whole, intrusion lifecycle. It would be better if we could throw up some alerts, some events earlier on. So we want to integrate cyber deception into AC Hunter. And like I said before, we wanted to maximize our impact with the minimal amount of effort. So we chose to target Active Directory, monitoring decoy users and files. And we do that by dropping an agent on the individual servers. We stream back any event logs that match the filters that we've set up. And if they match, then we store them on AC Hunter for a certain amount of time. And then we can cross-correlate all of those detections with the detections that we get from the C2 traffic, which means that an individual host score can go way up and you can get a really good, meaningful alert out of that. And the other nice thing about AC Hunter is that, it's pretty cheap when you compare it to a lot of the competition. So what's the workflow like if we want to create Honey token users and Honey token files using AC Hunter compared to everything we just logged through? Basically, it's a six-step process. You're going to log into AC Hunter. You're going to go to the Cyber Deception tab, click Create Token. That'll give you a zip folder that you're going to deploy onto the target machines that host the resources. You're going to import the accompanying PowerShell module, install the log forwarding service, and then you're going to use these PowerShell commands that can create ACES users, AC event service users, or register existing ones. So let's say that you did do some of this work by hand. You created a really convincing user that matches all of your organizational norms, and you don't want to use a template that we provide. You can call register ACES user and integrate that with the AC Hunter system. Same with the files there. So just taking a quick look at how that works out. We have the Create Token button over on the left. Once you enter this tab, it'll download the zip file for you. And here we can see a little bit of the contents of that zip file. One really nice thing that I had to do a lot of learning in order to implement was we distribute client certificates with each installation of the AC event service, which means that we can use mutual TLS to make sure that all of the traffic is authenticated and encrypted when we're sending those detections back to AC Hunter. So once you have the zip file deployed onto the system, we import the PowerShell module, we run install AC event service. It's going to ask you, how do I contact the server, the AC Hunter server? You can give it a domain or an IP. Then it's going to ask what data set in AC Hunter do you want to associate these events with. You run that, it's going to run through, create that inventory in AC Hunter saying, hey, we've got a new agent out there monitoring stuff. We're going to set up all of the auditing that we previously talked about. And then if we go and create a new ACES user, it's got a little bit of a template that it's going to ask you to fill out. Just give it the account name. It'll ask you to format an email address for that user. And then it's going to set up SPN for that user. Right now, it just defaults to Microsoft SQL. It's going to set up all the auditing, and it's going to register that new account with AC Hunter, creating inventory for that. And we can do the same thing with files. Here we see an example of deploying a setpasswords.bat file into sysvol, pretty similar to what we just did by hand. And it will call back to AC Hunter and make sure that the inventory is updated. And so once you get everything going, this is what AC Hunter ends up looking like. Over on the left, you can see the inventory of all of our registered agents that are reporting to the system, as well as all of the accounts and files that we've created. Over on the right, we can see detections. So in this case, I ran the password spray we ran earlier, I ran the Kerberos that we ran earlier, and I ran the find interesting domain share that we ran earlier. And we can see that all three of these triggered detections on the resources that we automated with AC Hunter. And if we go and we click into any one of these events, it'll actually pull up a little bit of a breakdown. And up at the top, we get some different fields. And then we have the actual raw Windows event log that produced it. And you could take this to go pull it out maybe of your SIM or look at the actual logs on the host machine for follow-up. And then like I was saying before, we have a trigger detection on a honey token, or in the UI, we call it a canary token, really pretty much the same thing. We can see that adds 100 points to the threat score for that host. That gets factored in along with any C2 traffic, any really long connections, or any C2 over DNS that we see. That's going to boost that host's total score up. And then eventually you'll get some sort of alert or detection heading out to Slack, Syslog, maybe your SIM. So now that we've finished talking about how we can automate this with AC Hunter, I want to talk just a little bit about how you can go further than just creating individual resources. Really, what you want to do, especially for larger environments, is to follow this chain that MITRE puts out in this paper over here that describes how you can create process around cyber deception in order to implement it effectively into your environment. And in particular, there's a lot that goes into modeling who you think your adversaries are going to be. So that's thinking about, what they're going to go after in different circumstances and how they're going to behave. You need to integrate the whole thing with a whole cover story in order to make it more believable, and then come up with steps to prepare, execute, and monitor that, like we talked about today. And maybe if you want to go further with this, you could leak some user credentials online with the username that matches your fake user, but a bad password. So that way you can lure them into attempting that login. Or if you want to go even further and you have some time to spare, you might set up some VPN credentials as a honey file, which links into a whole new network that is not related to your production network, but you have highly instrumented, so that way you can monitor their moves inside that network. And we would call that a high interaction honeypot, or in this case, a honeynet. And you can get a lot of recon information out of doing that. And so with that, I'm pretty much done. I'm going to go ahead and set it back on this slide and open it up for questions.
Logan?
Yep.
We had one person asking if the SB client and the detection client that you've been describing that sends the records from Active Directory, is that pretty much the same code, exactly the same code?
So right now they are separate. We're looking to unify the two forwarders in the future. Right now, the SB client uses Elastic Winlog Beat, and the cyber deception client is a C# application that we've developed ourselves.
Oh, fantastic. Thank you. If you don't mind, I might ask one of my own. If if there isn't a direct connection between where your AC Hunter server is and the Active Directory server that you want to monitor, what kinds of options would somebody have for getting those events back to AC Hunter?
There isn't too many options that you can do without creating some sort of direct traversal. You could create a tunnel. That would be one way, or another way would be to implement some sort of log forwarding. So Windows Event Collection and Windows Event Forwarding can be used in order to grab those logs off of those domain controllers, and then we can ship those logs from the collection point into AC Hunter. So that way you don't have the full-on direct connection between the two.
So if you even have a VPN between those two networks, that would be enough to be able to send those packets across?
Yep, indeed.
Oh, okay, great.
Logan, I got a question for the audience. So if you're listening, if you can hear me, if you're using Discord or if you're on Zoom, let us know if you've ever used Rita or used AC Hunter. So just let us know if you've used Rita or AC Hunter in the chat. And so that would be good. We got a couple people that both. Cool. And then Logan, have you thought about potentially, or Bill thought about creating like a CTF for AC Hunter that incorporates like cyber deception into it?
I would really like to. The problem is that it really involves so many different systems. You need a full-on Active Directory lab to even get started with the cyber deception that we're talking about here today. So I would love to create some sort of CTF or hack the box. Unfortunately, I think it requires a little bit too much infrastructure to get started with.
Yeah.
As long as we can get someone on this webcast to go and give us direct access to their AD infrastructure, I think we could have this set up this afternoon. Anybody up for that? Administrator access, please. Yep. There we go.
If anyone wants to set up their own home lab, Bill, have you ever done a webcast in Home Labs?
Home Labs, you got it. Absolutely. I didn't touch much on Windows. I will warn you that ahead of time.
Yeah.
But absolutely, over in the Black Hills YouTube channel, I believe there's building a Home Lab. And the nice part is you can set up any servers that you'd like. If you've got something like a subscription to a Microsoft license, or I forget what the Microsoft developer pack. I'm sure I'm getting the term wrong. You would be able to set up your own AD server and be able to use this on your own lab network.
Yeah. So this video on how to build a home lab is the most watched video that we've ever made at Black Hills Information Security.
Wow.
Countermeasures.
I give all the credit to John. John kicks ass. He's got. Yep. It's a fun one.
86,000 views.
Wow. Yeah. Very nice.
So there's definitely a lot of people out there that
now, we would have done better if we'd had more kittens. I understand that that's the one thing that makes a YouTube video truly take off is kittens.
Speaking on that home lab aspect, I will say that, when I had to go start learning this all a year ago, without my home lab that I have set up on ESXi, I would have never been able to pull this off. So follow that guide. Definitely. It's a great way to get started with playing with these sorts of tools at home.
And I did the same thing recently with VMware, trying to set up using VMware Workstation to have a whole bunch of virtual machines and be able to set up private networking inside of it. It means that you don't have to come up with hardware every single time you want to try a new operating system. The only problem is that VMware, the company, doesn't seem to want to sell VMware Workstation. I've never had more trouble in my life trying to buy a piece of commercial software than VMware Workstation. Anyway.
Well, Logan, any final thoughts today?
No, I think we're good.
All right. Well, everyone, thank you so much for joining us for this Active Countermeasures webcast today, where Logan talked about cyber deception and AC Hunter. If you want a demo of AC Hunter, you can always add the word demo inside of Zoom. If you say the word demo, then we'll have someone reach out and see if we can get you an actual demo of AC Hunter. That's something that you would like. So go ahead and drop that into there. Other than that, we will see you on the next Active Countermeasures webcast in the future. Plus, I'm pretty sure Chris Brennan at some point will do a 6-hour workshop in case you don't know much about thread hunting. That way you can learn. Or if you've already taken it before, you can take it again. Bill, any final thoughts from you before we head out?
This is wonderful. It is such this whole approach is so much easier than trying to go and set up a full system and all of the requisite pieces and the underlying testing. Whether you take the first approach that Logan described with running these commands by hand, or you take the approach of having AC Hunter provide a lot of these services on the top, this is much easier than the older approaches that used to take a lot of time.
Thanks, everybody. We'll see you next time. Ryan, go ahead and kill it with fire, my friend. Kill it. Kill it, Ryan.